All right, for A, they say Jose is blowing up a beach ball at a constant rate of 9 cubic centimeters per second. When the volume of the ball is 2048 over 3 pi cubic centimeters, what's the rate of change of the radius? Okay, and then they give you a formula for volume, and that's volume of a sphere. Okay, so first thing is, go through the problem. Maybe you don't have to, but I'm going to highlight kind of the phrases or sentences that get turned into math notation that we're going to collect over to the side. Okay, so first they say that Jose is blowing up a beach ball at a constant rate of 9 cubic centimeters per second. Okay, so that gets directly translated into, the beach ball is increasing at 9 cubic centimeters per second. So cubic centimeters is volume. So that's volume is changing per second, and that's changing with time. So that's dV dt, and that's 9. Okay, next thing they say is when the volume of the ball is 2048 over 3 pi cubic centimeters. So they're just saying when V is 2048 over 3 pi, you don't need units. Okay, and then they say what is the rate of change of the radius? So the rate of change of the radius is dr dt, and so that's what we're looking for. So put equals question mark so we don't forget while we're doing the problem what we're solving for ultimately. Okay, so once you do that, once you collect kind of all your expressions and math notation off to the side and then what you're looking for, just look at all the variables. So you have these, V is one of the variables and R is one of the variables. So we need an equation with V and R, and that's the equation that they gave us. Okay, once you have figured out or have that formula, take derivative of both sides. So derivative V is dV dt. Okay, and then we have this 4/3 pi as a constant. And we're times that by derivative of r cubed, which is 3r squared. And then for chain rule is you get dr dt. Okay, for this one we'll clean it up a little bit. Really cancel out those 3's. And so dV dt. Okay, so next thing I do is make sure that we have an expression for what we want, which is dr dt, and so we have that. We've got dV dt, they tell us is 9, but we don't have r. We're not actually given what the radius is at the moment that they're talking about. So in this case we'll have to solve for it. So notice that they gave you what the volume was. So they say the moment when the volume of the ball is 2048 over 3 pi, so they're saying at a certain moment, but we want to know what the radius is at that moment. But that's fine. So this volume we can just set equal to the formula and then solve for r. So we can say 4/3 pi r cubed is 2048 over 3 pi. Okay, so and then we'll solve this for r. So cancel out the pi's, cancel out the 3's, and then we can even divide both sides by 4. So 2048 divided by 4 is 512. So we'll get r cubed equals 512. And then we can take cube root of both sides. Okay, that cube root and cube cancel out. And just left with r is cube root of 512, which ends up being 8. Okay, so now we have everything we need. So we'll come back here and substitute. So dv dt ends up being 9. We can rewrite that as 9. 4 pi, and then we just found that this r is 8, so we can substitute that. Squared. Okay. Okay, and then 8 squared is 64, and 64 times 4 is 256. All right, and then just divide both sides by 256, and you get dr dt. All right, so that's the answer. Just have to remember at the last step, make sure you figure out the units. So remember, so notice I haven't done units at all. I haven't even thought about units. So the only time you really think about units is at the very end. So, and then kind of look at what you, the little expression that you're looking for, dr dt. So this is r in the top and t in the bottom. So r is radius, which is a distance. And distances are in centimeters, cubic centimeters we're given, so distance is centimeters. And then time was given in the rate that the ball is being blown up, which is per second. So time is in seconds. And that's it. Okay, so they're all very similar to this. Every problem, you know, read the problem, look at kind of each sentence or phrase, turn it into math notation, look at what they're asking for, you know, make sure you write that, maybe equals a question mark, or, you know, have some way so that you don't forget what you're looking for ultimately. Okay, and then find an equation that relates the variables that you're given and want. Take derivative of it, and then substitute the known values, you know, besides the thing that you're looking for. And then sometimes you have to solve for one of the variables. Sometimes you're just given everything and you can just substitute everything, and then solve for the thing you're looking for. And at the very end, figure out units. So in a general sense, I know kind of all of them have something a little different about them. Maybe the algebras for one is a little harder. Maybe getting the equation for one is a little harder. You have to think back to geometry, stuff you haven't done in a while. So I know some little differences, but in a general sense, the general steps are all almost exactly the same. So the only thing we didn't do in this one was draw a picture, because we didn't really need to. So some of them will draw a picture. A lot of them we will, but just not this one. Okay, so next one, B. Photographer stationed 250 feet from the base of a tall tree. She observes a koala bear climbing up the tree at a rate of 1.5 feet per second. At the instant when the koala bear is 5 feet up the tree, how fast is the distance between the photographer and the koala bear changing? Okay. So I think this one will draw a picture. Yeah, it just makes sense to draw a picture, I think, for this one. Okay, so they say the photographer is 250 feet from the base of a tall tree. The photographer is 250 feet away from the base, so this is the base of some tree. There's the tree. Okay, and when you're doing it, you know, obviously you don't have to label like photographer. I'm going to just while I'm explaining it. Okay, and then the koala bear is somewhere on this tree. I'll say the koala bear is there, climbing the tree. Okay, and think about if this koala is climbing this tree, that means the distance between the koala and the ground is changing, so we'll label that with a variable. So I'll label that with an H. So anything that's changing, any quantity that's changing, you label it with a variable. This, we didn't label with this with a variable because it's not changing. It's just a fixed value of 250. So you can label that with what it equals, its fixed value. Okay, then we can kind of finish off. This makes a right triangle here, and then it makes sense that as this koala climbs, then the distance between the photographer and the koala changes, right? As this koala climbs higher. So let's label that with a variable. I'll call that maybe C, like we do for hypotenuses. Okay, so let's collect everything off to the side. Okay, so they say she observes a koala climbing up a tree. So a koala bear is climbing up a tree at a rate of 1.5 feet per second. Okay, so in this case, when the koala is climbing up this tree, h is changing. So that means that's dh dt that we're given. And that's 1.5. That's positive because as the koala climbs, h is increasing. Okay, next thing they say, at the instant when the koala bear is 5 feet up the tree, okay, at that instance, h is 5. Okay, and then they ask for how fast is the distance between the photographer and the koala bear changing. Okay, so the distance between the koala bear and the photographer is c, so how fast that's changing is dc dt. Okay, so variables we're given are h and c, or the variables that we're kind of given and want are h and c, variables involved. And so we can see by this, if we do Pythagorean theorem, that'll give us an equation involving h and c, those same variables. So definitely do Pythagorean theorem. A lot of times when you have a right triangle, you're either going to do Pythagorean theorem if you're just focusing on the sides, or if there's an angle involved, you might do SOHCAHTOA. It's kind of common also with right triangles. But okay, so we'll do Pythagorean theorem. So we'll say like 250 squared plus h squared equals c squared. All right, and we'll take derivative both sides. So derivative 250 is 0, so that'll go away. Derivative h squared is 2h dh dt. Derivative 2c, or c squared, is 2c dc dt. Okay, if we want, we can cancel out those 2's, divide both sides by 2, just to simplify it. Okay, now look back. So we want dc dt. Okay, so that's good. That's in our expression. We're given h and dh dt, but we're not given c, so we have to go back and solve for it. So not uncommon. So we're given h here, and so now we can plug it in and solve for c. Okay, so let's do that. So 250 squared plus h is 5, so 5 squared equals c squared. Okay, 250 squared is 62,500. Okay, so c equals really the square root of 62,525. Okay, so yeah, that's it. So now we've got everything we need. We're looking for dc dt. Now we have c. We're given h and dh dt, so we'll just substitute everything. Okay, so h is 5. Okay, times dh dt was 1.5. And then c is square root 62525. All right, and then really 5 times 1.5 is 7.5. And then just divide that by that square root. Okay, and then that we can say equals, if you do this in a calculator, 0.030. It's really 0.0299, I think it was. So that's 0.030. And then just got to do units. So c is a distance. So distances in this case are in feet. And then t is in seconds. So this is feet per second. All right, so the next one says a square is inscribed in a circle as shown below. The radius of the circle is decreasing at a constant rate of a half centimeter per second. So I'm just going to go right into writing these sentences or phrases as in math notation. So the radius of the circle is decreasing. Radius of the circle is decreasing at a rate of 1/2 centimeter per second. So, whoops. So that's dr dt. It's decreasing, so it's negative, and it's decreasing at a 1/2 centimeter per second. Okay, keep going. So they say when the radius is 4√2 centimeters, so when r is 4√2, what's the rate of change of the area of the shaded region? So they want dA dt, and they want that shaded region that's found outside the square but inside the circle. Okay, so we'll say that equals question mark, and just realize that that area, that A and dA dt, it represents that shaded area. So we'll have to get a formula that represents that shaded area. Okay, so definitely going to, we're given the radius and the rate of change of the radius. So definitely want to represent the radius in here. Okay, then we can kind of do this different ways. So I'm going to do it kind of differently than I did in class, just because, just to see that just one way of doing it isn't the only way of doing it. So think about if I did this. That's a radius also, and this makes a right angle. Okay, do you notice that these are both 45-degree angles? And that now this here, this side of the square becomes a hypotenuse of this 45, 45, 90 triangle. That's 45 and that's 45. Okay, and then now we can just see that this is r√2, right? So for the 45, 45, 90 triangles, whatever these legs are, times it by √2, and you get the hypotenuse. Okay, so just seeing if you can kind of notice little things, they make things go quicker, but a lot of people got the answer doing it kind of a more standard way, I guess. Okay, so now we want to ultimately, and I should have started here, we want to get the area of the shaded region by finding the area of the circle and then subtracting the area of the square. So the area of the circle we can get in terms of the radius, just pi r squared. And then now that we've represented the side of the square, we can just square this side of the square to get the area of the square, right? Because if you have the side of the square, you square it to get the area. Okay, and then now we'll subtract those. So now the area that we're looking for, area of the shaded region, is area of the circle, so pi r squared, and then minus the area of the square, which is the side length, squared. So we'll clean that up. Area equals pi r squared. So when you have two things multiplied raised to an exponent, you raise each of these to the exponent. So that r gets raised to the 2. So that's r squared. And then this root 2 gets raised to the 2, and that, root 2 squared is just 2. Okay, if you want, you don't have to, but you could even pull out the r squareds, and you'll be left with pi minus 2 times r squared. Okay, and this is the way I would do it, but you don't have to. So, all right. So now we can. Now we've got it all in terms of one variable. A lot of times you could call this s, this side length, and then you'd have to kind of solve or figure out how to. This would initially be in terms of r and s, and you'd have to somehow get it in terms of r by substituting. So now you can see there's a little quicker way, maybe. Okay, so now take derivative both sides. So dA dt. Just rewrite this constant. Pi minus 2 is just a constant. Derivative of r squared is 2r dr dt. Okay, so let's see if we're missing anything. So we want dA dt. We're given r and dr dt, and that's the only two things we need. So now we can just substitute. So this is times 2r, whoops, r is 4 root 2, and dr/dt is negative half. Okay, so I'm going to do a couple things. I'm going to cancel out this half and that 2 cancel. And then I'm going to apply this negative to these two things subtracted. So remember when, just a little algebra reminder, if you do negative, apply negative to two things subtracted, all it does is really switch them. So I'm going to apply this negative to these two things subtracted. I'll start over here again. And so when we apply this negative to this term here, it'll switch those. Okay, times 4 root 2. Okay, yeah, that's it. So here, let's see, as a decimal, maybe I'll write the decimal version, just so that we can all get the same thing. Oh no, wait, what's the decimal version? Okay, so it ends up being negative 6.4578, so 458. Okay, and then that will be dA dt, so area. So the distances are in centimeters, so area will be centimeters squared, square centimeters. And then time is per second. Okay. Okay, next one they say, water is dripping through a conical coffee filter at a rate of 11 cubic inches per second. The base diameter of the cone is 8 inches and the height is 6 inches. How fast is the water level in the cone changing at the instant when the depth of the water in the cone is 5 inches? Okay, so I had to read the whole thing just to make sure. So they say water is dripping through a conical coffee filter. So that means like water is in the coffee filter and it's dripping out, just like a coffee filters do. So here, I'll draw a picture real quick. Whoops. Okay, so we've got, here's the top of the cone. Okay, and then that's the actual cone itself, but then there's like coffee in here. Okay, and this is all just kind of filled with coffee here. Okay, so they say water dripping through a conical coffee filter at a rate of 11 cubic inches per second. So now we know the 11 cubic inches per second. Cubic inches is volume, so that's dV dt. And it's dripping through, so that means that this water is going to be decreasing. This volume is going to be decreasing. And then at that rate that they say, which is 11. Okay, they say the base diameter of the cone is 8 inches. Okay, so we'll write that. That's not changing, so we can actually label that with the thing that it equals. We don't need a variable. And then the height of the cone, they tell you, is 6 inches. Okay, and then they say how fast is the water level in the cone changing. So they want to know, let's say we call this H here, up to here, so that's like the height of the water. That's taking the shape of the cone. So then where they want to know, so when they say how fast is the water level in the cone changing, they're asking for dH dt. That's what we're looking for. And they say at the instant when the depth of the water is 5 inches. So that's really when the height for us is 5 inches. Okay, and then think about now we'll label this as R. See it very well, but so that's R there. Okay, so this, this is the water that's taking the shape of the cone. The radius of that water that's in the shape of a cone is, we'll call R, that's changing, and the height is changing, so we'll call that H. Okay, so now we've collected all the math symbols that we are given. Now we'll find a formula that relates the variables, so V and H. So we got this extra R in there, maybe we'll try to get rid of it, but at least this volume relates some of the variables that we're given and looking for. Let's write that off to the side. I'm just going to write that 1/3 pi is just pi over 3. Like that. Okay, so now think about, we're given H and we want dH dt, so nothing about R. We're not given R, we don't want R. Nothing about dr dt or anything, or R. So we want to try to get rid of this R if we can. Okay, so to get rid of a variable by substituting, we want to find a separate equation where we can, is R equals something in terms of H. You want to get an equation that involves the variable that you want to get rid of, and then have it equal the other variable that's in the formula. So we want to get an equation that involves R and H, and so we'll do similar triangles, just like we did in class. Okay, so these are right triangles, and they're similar. So we can set up a proportion. So you can do it different ways. I'm going to do R over H equals 8/6. And that means R equals 8 over 6 is 4/3, and then just multiply by H. Okay, so now we can take this, what R equals, and substitute it in for this R. So we have volume. Okay, and that R is 4/3. Okay, and then we've got H, and that's 5. Oh wait, what am I doing? We haven't taken derivative yet. I don't know. Sorry. We got to take derivative first. Sorry. So that's a good lesson. So we're not going to, yeah, sorry, we're not going to plug in that R yet. I don't know why I was thinking that. Actually, I shouldn't have, it doesn't matter, but I shouldn't have done this yet. Oh no, I don't know. I should have. I don't know what I'm thinking. Yeah, sorry. We just, I forgot the H. I don't know. Sorry, I made a little mistake that you won't see. Anyway, sorry. So this R, this 4/3 H is going to get plugged in for that R. This is 4/3 H squared times H. Okay, let me rewrite that. Okay, so this 4/3 will get squared to become 16 over 9, and then times 3, that'll be 16 over 27. I'm going to write it as 16 pi over 27. Kind of group all those constants in one fraction, and then you'll get an H squared times H, so that'll be H cubed. Okay, now we take derivative both sides. So dv dt. Okay, now we've kind of planned it out, so we have everything we need. So we have H, we're given that. We have dv dt, we're given that. And we want dh dt, so that's perfect. Okay, so dv dt is -11. And actually, I'm going to cancel these out. So that 3 and that 27, that'll become a 9. Okay, and then H is 5. Okay, so this will be 25, and you could times it by 16. So 25 times 16 is 400, I think. Yeah. So this is 400 pi over 9. Actually, I'll write that. Okay, and then just algebra. You know, multiply both sides. You want to get rid of this fraction. So technically you're dividing by this fraction, but better to just multiply both sides by reciprocal. Like that. And then so that's nice. You know, the 9's cancel, the 400 pi's cancel, if you want to look at it that way. So now we're just left with dh dt. That's negative. And then this 11, we know when a number is multiplied by the fraction, you know, especially a whole number, just multiply it by the top. This is negative 99 over 400 pi. Oh wait, did I make a mistake? Sorry. Okay, sorry, I just realized. Okay, let me fix that real quick. I made a mistake. So they said I'm not going to fix it. I'm not going to go back and edit it, but I'm just going to say it. So they said the diameter is 8. So that means the radius is 4. So I'm just going to go back and kind of fix that. All right. Not good, but okay. So let's fix that. So that 8 in the picture, I'm going to change to a 4. Okay, so that got changed to a 4. That'll change this 8 to a 4, and that'll change this 4 to a 2. Alright, so let's do that. Okay, and then that'll change this to a 2, and that'll change this to a 4. That'll be changed to a 4. So I'm just kind of going to change everything. That's going to become a 2. That's going to become a 4. That's going to become a 4, and that's going to become a 4. 2, 4, 4. Okay, so that makes the 400 just a 100. So that 400 is really, whoops. Just do that. Okay, and then that makes the answer, the final answer, 100 pi in the bottom. Alright, so I just made a little mistake. Easy to make mistakes. Okay, and then I'll write it as a decimal also. So decimal is, so it'll still be negative, and it'll be 0.3151, so 0.315. Alright, so units, h and t, so distance and time. And distance in this case is inches, and time is in seconds, so this will be inches per second. Alright, so I wasted a little time. Whoops, Jesus Christ. That's okay. Alright, and you could actually, this is good also, if you left it like that. Okay, next one. For E, they say rice is being poured into a cylindrical container with a radius of 4.5 inches. So the height of the rice is increasing at a constant rate of 0.5 inches per second. Okay, so we know at least the height of the rice is increasing at a constant rate of 0.5 inches per second. So that means we know we'll write dH dt. Is increasing, so it'll be positive at 0.5 inches per second. They say, what rate is the volume of the rice in the container increasing? So they want to know dV dt. Okay, at the instant when the height is the same as the radius. So they want to know when h equals r. Okay, at that instant. Oh, I see. Okay. So this is an interesting one. So let's draw a picture, and then I'm going to kind of revise this now once we draw the picture. Okay, so we've got a cylindrical container. rice is being poured in this. So we'll just say like this is kind of the rice here. It's kind of acting like a liquid being poured in there. Okay, so the rice will, as it's being poured in, will have a certain radius. And that radius isn't changing. That radius is just the radius of the container, and that's 4.5, so we'll label it with 4.5 since it's not changing. Okay, the height is, this distance here. Okay, that will be changing, so we'll label that with h. Okay, so now we kind of see when they say at the moment when the height is the same as the radius, they really say, let's update that. Instead of h equals r, they're really saying when h equals 4.5. That's the radius. Okay, so they say, they give us the volume of a cylinder. And so we'll use that. So let's write that off to the side. Okay, so normally we just take derivative right away, or we'll substitute it to get into terms of one variable. This one's different because since this radius is not changing, you can plug in its value before you take derivative. So I think that's like an important thing to understand. When you've got your formula that you're eventually going to take derivative of, any value that's not changing, any value of a letter basically that's not changing, you can plug in before the derivative. But any value of a letter, which is really a variable, like in this case h, since h is changing, you can't plug in this 4.5 until after you take derivative. So things that are changing, plug in after you take derivative. Things that aren't changing, plug in before you take derivative. Okay, so we'll say, oh, whoops. Okay, so let's plug in that r is 4.5. Okay, and then I'll simplify that in a calculator. 4.5 squared is 20.25. And then that's times h. Okay, so this will be a nice kind of simple one. So now take derivative both sides. And derivative of h is dh dt. Didn't even have a chain rule in this case. Okay, looking for dv dt. And we've got dh dt, which is 0.5. Okay, normally you want to avoid having decimals times pi, but since we were given in terms of a decimal, we'll just keep it. So, okay, and then 20.25 divided by, or times 0.5. Is 10.125. And we'll just leave it at that. So you could change it to 81 pi over 8. That's another way to write it, but we'll just leave it like that. So that's fine. dV dt, so volume is cubic units. So the units are inches. So this is cubic inches. And then time is in seconds. So that's it. Okay, so for the next one, they say if the circumference of a circle is increasing at a constant rate of 4 feet per second, so dc dt equals 4, positive 4 since it's increasing, how fast is the surface of the area changing? Surface area changing, so we'll just say A for area. They want to know dA dt. at the instant when the radius is 7. Okay, so I'm going to start doing these a little quicker. So they say they want d/dt, so we'll get area. So area of a circle, pi r squared. Okay, it's in terms of one variable already. So take derivative of both sides. We'll see. Maybe we don't have everything. Maybe we do. We'll see. So take derivative d/dt, 2 pi r dr dt. Okay, we want d/dt. We've got r, but we don't have dr dt. Okay, so we're given dc dt, but not dr dt. Okay, so this one's just a little different. So think about it. If you're given dc dt, that's circumference. Circumference, which is 2 pi r. So do you see how you can take derivative of both sides? You get dc dt equals 2 pi dr dt. And then you can plug in the value for dc dt and then solve for dr dt and then plug it into the original formula that you took derivative of. Okay, so let's do that. Okay, dc dt is 4. dt is really 4 over 2 pi, which is 2 over pi if you simplify it. Okay, so now we have everything we need. 2 pi r is 7, and dr dt is 2 over pi. Okay, the pi's cancel, and just 2 times 7 times 2 is 28. Okay, so that was kind of a nice simple one. One little weird thing where, you know, they gave us the derivative of a certain variable, but we needed the derivative of another one. So we got a formula that had both of those so that we could take the derivative and then solve for the one that we wanted. So okay, units. So area is squared units, squared distance. So distance is in feet. So this is square feet, and then time is in seconds for this one. So yeah, circles are usually the easiest figures to work with, because they're only in terms of one variable. Yeah. Okay, so they say the paths of two runners cross at a stop sign. Okay, one runner is heading south at a constant rate of 6.5 miles per hour, while the other runner is heading west at a constant rate of 7 miles per hour. How fast is the distance between them changing after 10 minutes? Okay, so I'm going to draw a picture for this one before I do anything, and then we'll go back and reread it. Okay, so the runners cross at a stop sign, so we'll say that's the stop sign, and that's where they'll cross, so they intersect there, they're there at the same time at some point in time, but then they keep going, and one runner keeps going and is headed south, okay, at a rate of 6.5 miles per hour, and the other one is headed west at a rate of 7 miles per hour, a little faster. And they want to know what's the distance between how fast is the distance between them changing at a certain point in time. So might as well represent the distance between them like this. Okay, so let's represent things with variables that are changing. So this distance is changing, this distance is changing, and this distance is changing. Okay, so I'm going to represent all of those with variables. So I'll call that A, B, and C. Okay, so let's go back and now reread the question and collect the math symbols over to the side. So One runner is heading south at 6.5 miles per hour. So this distance is increasing at the rate of 6.5 miles per hour. So dA dt equals 6.5. Okay, same idea, dB dt is 7 because the runner that's, oh, whoops. Sorry, the other way around. I don't know why, did I read that weird? So south is this here. So dB dt is 6.5 and dA dt is the runner heading west, and that's 7. So let me fix that. Wait, dB dt is south. Okay, that's 6.5. That's 7. Okay. How fast is the distance between them changing after 10 minutes? Okay. So far we don't know how to use that 10 minutes, and we don't know how to solve for, we're not given A, B, or C. But we know when they say how fast is the distance between them changing after 10 minutes, we want to know the distance between them changing, so that's dC dt. Okay, so let's not worry about that yet. Let's just keep plugging forward like we would normally, and then we'll see what we need so that we're not doing too much work. Okay, so this is a right triangle, and we're given the sides of a right triangle. Those are the variables, so it makes sense to do Pythagorean theorem. So we'll do a squared plus b squared equals c squared. We want dc dt, so we'll take derivative. So 2a dA dt plus 2b dB dt equals dC dt. Okay, I'm going to cancel out all those 2's, just divide both sides by 2, and all those 2's cancel. Okay, so now think about what we're given. We're given dA dt and dB dt, and we want dC dt. So we have 3 other unknowns, which are all the sides of the triangle. So we need to find the sides of the triangle. Okay, now think about this. If this runner is running at 7 miles per hour for 10 minutes, that means we know the rate and the time, and then we can use the formula rate times time equals distance. Okay, so we can get these distances, at least these 2 distances, by just doing rate times time. We'll do 7 miles per hour times 10 minutes and 6.5 miles per hour times 10 minutes. The only thing is this is miles per hour. These are both in miles per hour, but this is in minutes, so we have to use the common units. So this 10 minutes here, so 10 minutes is a sixth of an hour. So we'll change this. We'll use 1/6 of an hour. Okay, so that means that that distance is rate times time. So that rate is 7 times time is 1/6. So A is 7/6. So I'm going to write that down here. Okay, same idea with B. 6.5 is its rate times 1/6. We'll just say 6.5 over 6. That's B. Okay, we could also say it's 65 over 60, and then divide top and bottom by 5, and then that's 13 over 12. I'm actually going to do that. Okay, or just times top and bottom by 2. 6.5 times 2 is 13. 6 times 2 is 12. That's probably better, actually. Okay. Okay, and then, so we've got almost everything we need. We've got A and B, but remember we still need this C. So now we'll go back, do Pythagorean theorem. So we know we've got A squared plus B squared is C squared. And then plug in those values of A and B. that's 7 over 6 squared plus 13 over 12 squared and equals c squared. Okay, so I'm going to do a common denominator before I do anything. So I'm going to be thinking of this 7 over 6 as 14 over 12. And this is 13 over 12. So, okay, so 14 over 12 squared, 14 squared is 196 over 12 squared, which is 144. Okay, 13 squared is 169 over 144. That equals c squared. So that means that c is the square root of those two fractions added. So 196 plus 169 is 365. Okay, and then we can write that as square root of 365 over 12, maybe. Okay. And I don't think square root of 365 can be simplified, but I'm not sure. But that's fine. We'll just leave it like that. All right, now we've got everything that we need. I'll even just put it over here just to see that we have everything collected over to the right, just to be organized. All right, so now let's go back to the equation that has the dc dt that we're looking for and substitute in all the values now. Okay, so a is 7 over 6. So just got to be super careful not to make a mistake. dA dt is 7. I'm just going to put everything in parentheses. Okay, b is 13 over 12. Okay, dB dt is 6.5. I'm going to write that as 13 over 2. dB dt, 6.5 is 13 over 2. I'm going to write everything as fractions. Okay, c is square root of 365 over 12. And then dc dt is what we're looking for. Okay, to get rid of fractions, just a little algebra stuff. This is what I'm just doing what I would do. So I would multiply this whole equation by the least common denominator of all the denominator. You know, this denominator would end up being 24. So you'd have 6, 24, and 12. So 24 is the least common denominator, and that's what I'd multiply by every term. Okay, when you multiply this by 12, it'll cancel out with the 6 to be, or by 24, sorry. Multiply this by 24. The 24 will cancel out with the 6 to be a 4. So it'll be 4 times 7 times 7. So it'll be 4 times 49. Okay, when you multiply this denominator, which is 24 by 24, they cancel. So that just ends up being 13 times 13. Is 169. Okay, and then multiply this denominator. 12 will cancel out with the 24 to be 2. So that'll be 2 square root 365. So I'm not simplifying because I have to. I'm just simplifying because it feels to me like it'll be easier to not make a mistake if I simplify. So that's the only reason I'm doing it. Okay, so now 4 times 49 is 196 plus 169. Okay, we already know 196 plus 169 is 365. And then now we can divide. All right. Okay. And then I'll do like a little idea in algebra. Wait, did I make a mistake? Hold on. Okay, yeah, I think that's good. Okay, and then just a little algebra idea. I'll do it kind of up to the left, up there. So, just in general, if you have something divided by the square root of the same thing, a divided by square root of a, that's just square root of a. So just kind of nice to know that. So that means this whole thing is just, you have a divided by square root of a. So this is just square root of a. So square root of 365 in this case. And then just divided by 2. Okay, and that ends up being 9.5 rounds to 9.552. And then this is dc dt. C is a distance, and distances are miles in this case. And time is in hours. We did everything in hours. So okay, so that's it. Okay, so that was a long one. A lot of work for that one, and you know, same general steps, but just little differences. You know, so a new thing that we learned was sometimes you have to use this rate times time equals distance, right? They gave you the time and their rates, so we had to multiply them to get these distances here. We have to solve for this using another quantity using Pythagorean theorem. Yeah, so and then we just had a bunch of values to substitute in. Okay, so just a lot of algebra, a lot of simplifying, a lot of algebra when we had to solve. So okay, so that's good. That was a good problem to learn from. Okay, next one, they say the radius and height of a cone both increase at a constant rate of 1.5 centimeters per second. At what rate is the volume increasing at the moment when the height is 6 centimeters and the diameter is 18 centimeters? Okay, so this is just a single cone. This isn't like a cone within a cone kind of thing. So this is going to be a little easier. So they say the radius and the height both increase at a constant rate of 1.5 centimeters per second. So that means that, dr dt equals 1.5 and dh dt equals 1.5. At what rate is the volume increasing? So they want to know what's dv dt. Okay, at the moment when the height is 6 and the diameter is 18, so I gotta be careful. Last time I messed that up. So diameter is 18, but we're gonna really end up wanting radius. So radius would be 9. Okay, so we want dv dt, and so we've got this formula for volume. So kind of plan ahead. If we take derivative of this just as it is, not get it in terms of one variable, we can see that we're going to get an r, a dr dt, an h, and a dh dt, and we have everything, so no problem. We'll just substitute it in and solve. So this will be kind of a nice, more simple one, I think. Okay, so I'm just going to take derivative of this formula above. This is really pi over 3. I'm going to kind of pull that out and then just kind of take derivative of this r squared h. Okay, so derivative of r squared h, so do product rule. Derivative of r squared is 2r dr dt, and then times h plus r squared times dh dt. Okay, now we've got all those values that we can substitute in. So this would be, how can I do this? So 2, and then r is 9. dr dt is 1.5. H is 6. Okay, r squared is 9 squared. dH dt is 1.5. Okay, so I don't know what the best way to do this is, but 1.5 times 6, that's 9, times 9 is 81. 81 times 2 is 162. Okay, and then this, oops, here's 81 times 1.5. I'm just going to do that in a calculator. So that's 121.5. So add that to 162. You get 283.5. I'm going to change that to a fraction just because I feel like it. That's 567 over 2. Okay, so final answer, 567 pi all over 6. Okay, and actually 567 is divisible by 3, I think. Wait, yeah, it's divisible by 3, and that goes in, divide by 3, you get 2, divide by 3, you get 189. Okay, so final answer, dV dt, most simplified, 189 pi over 2. Okay, and then volume is cubic units, so that's centimeters, cubic centimeters, and then time in this case is in seconds from above. Okay, next one they say in a triangle the base is increasing at a constant rate of 2.8 centimeters per second while the height is decreasing at a constant rate of 0.7 centimeters per second. At the instant when the base of the triangle is 6 centimeters and the height is 10 centimeters, what's the rate of change of the area? Okay. So here, let's write everything in math symbols. So the base, I'm going to call that a, yeah, just call that B. Okay. Whoops. So the base is increasing, so dB dt is a positive 2.8. The height is decreasing, so dH dt decreasing, so that's negative 0.7. They say at the instant when the base is 6 and the height is 10, what is the rate of change of the area? So they want dA dt. Okay, so all our variables are A, B, and H. So area is 1/2 base times height, so we'll definitely use that. Alright, so we'll just take derivative just like it is. Pull out the 1/2 and then do the product rule with the rest. So dB dt times H plus dH dt times B. We've got everything, so we'll just substitute. Okay, dB dt is 2.5 times H, which is 10. dH dt is negative 0.7, and B is 6. Okay, 2.5 times 10 is 25. This would really be minus 0.7 times 6 is 4.2. Okay, 25 minus 4.2 is 20.8 divided by 2. Oops. So now we'll say dA dt is 10.4. Oh, I did that. I wrote that wrong. Hold on. I'm sorry. Let me fix that. That's easy to fix. I put 2.5. You probably saw that from the start. It should be 2.8. Let me fix that. Okay, that's a 2.8. 2.8. So that'll be a 28. Let me fix that first. Okay, 28 minus 4.2. 20 minus 4.2 is 23.8. And then divide that by 2, that's 11.9. Okay, and then dAdt, so area is square units, so square distance, which is centimeters squared, square centimeters. And then time is in seconds. Alright, so super easy to make a mistake. I made a couple. Alright. Okay, last one they say the edge of a cube is growing at a rate of 6 inches per second at the instant when the edge of the cube has a length of 11 inches. Okay, what's the rate of change of the volume of the cube at that instant? Alright, we don't really need to draw a picture, but we'll just draw a quick picture. Just, I don't know. Okay, so they say, all the edges are the same. We'll call those S. Edge of a cube is growing at a rate of 6 inches per second. So ds dt is growing, so it's positive 6. They're talking about an instant. At the instant when the edge of the cube is 11 inches. So when S equals 11. And they say, what's the rate of change of the volume of the cube? dV dt at that instant. Okay, so volume of a cube is S cubed, just length times width times height, but S times S times S. So we'll take derivative. Okay, we've got everything we need, so we just substitute. So that's 18 times 121. And that's 2178. So dV dt, 2178. And then that's V over T, so that's cubic inches over seconds. So nice little simple one to finish it off.